That tells me what about my two numbers? So if you have two numbers that multiply to get a positive, they either both have to be negative or they both have to be positive, right? So if your AC is positive, your numbers have the same sign. If your AC is negative, your numbers have opposite signs. So then in this case, you're right, they both have to be negative because they add to a negative, right? If we added two positives, we would get a positive. So the only choice is for them both to be negative. So we have 1 and 6 or 2 and 3. They both have to be negative. And so -2 and -3, 4. And you can see, like, sometimes if you did a positive and a negative, you could get -5, right? But it wouldn't work because -6 times +1 is a -6, not a +6. So sometimes it's tempting to change the signs to make B work, but then you have to like double check that you haven't messed up the sign of your AC, of your product. So we have 6x squared minus 2x minus 3x plus 1. Factor out a 2x. And then so we have 3x minus 1 times 2x minus 1. Any questions on this process? It's going well on the homework and stuff. Okay, so one notation thing, well, it's not even a notation thing, it's kind of a value thing, but let's do this. Let's factor I don't know, like 5x squared plus 6x plus 1. Everybody's positive, so I'll tell you right off the bat, both your numbers are going to be positive. So see what you get on that. It should go fairly quickly. But I just kind of want to see what we write. Right, because if it was a 0, this would be gone completely. So that x plus 1 was equal to 1 times x plus 1. If you get two numbers that multiply, so that's 6 and added to 5, as opposed to multiply. think it's easier if you guys see it on each other's work. Than I try to explain it to you. Rotate. Come on. No. This one, and then this one. Can we see them both? Okay. Do you guys see any difference in this? I mean, other than the factors being in the opposite order, which is totally fine. So the yeah, so when we group these guys, those two groups are being added, right? And so when we factor the GCF out of the first group and the GCF out of the second group, the operation between these is addition until we factor out that common factor. So if I write it like this, I'm saying x times 5x plus 1 times 1 times 5x plus 1, right? So it's really common when there's addition there for people to forget the addition. Like when it's a negative, everybody remembers to take the negative out. But you want to remember that you have two terms there and that you have addition between your two terms. And just be sure that it's not multiplication until the very end, because that's when we actually factor. Does that make sense? And so it seems like a really small thing because it's just a plus sign, but it's one of those places where you actually are saying a different mathematical operation by forgetting that sign, and so that can trip you up as you go on and think that that's multiplication eventually. Does that make sense? Thank you guys for letting me use yours. Let's see. Okay, so let's talk about two-term polynomials. So, like I told you guys yesterday, we're not trying to have like different strategies for every single different kind of polynomial. So we're kind of just building on itself, like on what we've already done. So when I had 3 terms, I was like, oh, I'm going to write that with 4 terms because then I can factor by grouping. Well, we're going to use the same idea with 2 terms. So when I have 2 terms, I'm going to write it with 3 terms. So I can then write it with 4 terms. And then I can factor by grouping, which sounds like a lot longer of a process than it actually is. Because writing it with 3 terms is just a matter of putting in a 0. So if we have 2 terms in the polynomial, we are going to rewrite with 3 terms by inserting a term with coefficient zero as the middle term. And that's okay because I can add 0 to anything without changing its value, right? So if I just put a 0 in as my middle term, it's not going to change the value of my expression. So let's look at what this looks like. Suppose I want to factor 4x squared plus 3. So we're going to put a 0 in as our middle term. So our first term is 4x squared. And then our middle term is going to be 0. But in order for all of this to work out nicely, we have to have a variable factor there. And to choose what your variable factor is going to be in that middle term, you want your exponent to be half the exponent in the first term. So in this case, it's similar to what we've been doing over the past couple days. It's just x squared and x. However, if that had been 4x to the 6th, I would have put a 0x to the 3rd there. So plus 3. And so at this point, that 0x is just kind of a placeholder. However, it gives me a b to work with when I do the AC method. So now that I have 3 terms, I'm going to say AC equals 12. And then now b equals 0. So if AC is positive, what does that tell me about my 2 numbers? Yeah, they either have to both be positive or both be negative. My 0 doesn't really help me much on this one as far as which it is, so I'm just going to write them both. But that kind of presents a problem, right? Because if you think about starting with a positive number, if you add another positive number, you're getting further away from 0. And if you start with a negative number and you add another negative number, you're getting further away from 0 in the other direction. So it's impossible to add 2 positive numbers and get 0. And it's impossible to add 2 negative numbers and get 0. So the only way for this to work would be if I had opposite signs. That doesn't mean we get to just change them, though, because that would mess up the sign of AC. Since there are no 2 numbers that multiply to a positive 12 and add to 0, this polynomial is prime. It can't be factored. So prime means the same thing for polynomials as it does for like whole numbers, that the only factors it has are itself and 1, so we can't break it down into smaller polynomials. But we learned something important from this, even though it was prime, which is that if I have any hope of my 2 numbers adding to 0, they have to have opposite signs. And if my 2 numbers have opposite signs, that would mean AC is negative. So really, I have no hope of factoring a 2-term polynomial unless my AC is negative. Does that make sense? Mm-hmm. So let's try one where AC is negative. Like maybe I'll just go like this. And now my C is negative, so that'll be helpful. So again, we're going to put that 0 in. So plus 0x minus 3. And so now we have AC equals negative 12 and B equals 0. And now I'm hopeful because my AC is negative, which means I need 1 of each sign, right? I need 1 positive, 1 negative. So now we'll make our list 1, 12, 2, 6, 3, 4. Make one of them negative. But then we run into more trouble because in order for 2 numbers to add to 0, not only do they have to have opposite signs, but they have to actually be opposite numbers. Like they have to have the same magnitude, but with opposite signs, right? If one number has a larger magnitude than the other, it's going to outweigh it, right? So if the positive number is bigger, then you're going to end up with a positive when you add them. And if the negative number is bigger, you're going to end up with a negative when you add them. So really the only way to add to 0 would be if I had a number I could multiply by itself to get 12, right? So that like I could end up with something like 2 and negative 2, because those add to 0, right? But unfortunately, there is no number you can multiply by itself to get 12. And so again, this is prime. Do you know what we call numbers that, like, how can I word this? That have a number that you can multiply by itself to get that number. Like, what do we call numbers like that? Like, if we had a number that we could factor into, like, 4 and 4, or 6 and 6, or 2 and 2. You know what we call this? We call them perfect squares. So like 4 is 2 times 2, right? And 9 is 3 times 3. 16 is 4 times 4. And so we call them perfect squares because we can take some number and square it to get that number. So 12 is not a perfect square because there's no number you can multiply by itself to get 12. Well, no rational number you can multiply by itself to get 12. So in addition to having my AC be negative, I also want my AC to be like a perfect square, right? So, and these things I'm bringing up are just patterns. Like, it's not like you have to memorize all this stuff that I'm telling you about, like negative and perfect squares and stuff. But as you start to notice these patterns, you'll be able to take some shortcuts when you factor, which are really helpful. But you have to really understand when you can use them and when you can't in order for them to be really useful. So that's why I'm pointing out some of the patterns that we're noticing about what works and what doesn't work. So you can start to see like the types of things you can factor. So we're going to factor 4x squared minus 9. Again, we're going to put that 0 in. So we have 4x squared plus 0x minus 9. So my AC is negative 36, and my B is 0. Well, my AC is negative, so I'm going to have a positive and a negative. And then the number 36 is a perfect square because it's just 6 squared, right? You can take the square root of 36. And so the square root of 36 is 6, which means my numbers are negative 6 and 6. And if, again, if it didn't occur to you to like take the square root of 36, that's fine. Just make your full list and figure out which one works. So like the brute force method of just making the list and using the AC method, like, always works. Again, there's just some patterns you can notice that'll make things go a little quicker once you start getting the hang of them. So we have 4x squared minus 6x plus 6x minus 9. I'm going to run out of room, I'm sorry. There. So I'm going to factor a 2x out. And we have 2x minus 3. And then factor a positive 3 out. And we have 2x minus 3. And so it factors in a 2x minus 3 times 2x plus 3. And the final step in our factoring strategy, if we go back to our list, is to factor further if possible. And all we mean by that is that once we've factored a polynomial into the product of two polynomials, it's possible that one of those polynomials can also be factored. So just like when you do a prime factorization, if you have like the number 50, you're like, oh, that's 2 times 25, and then you notice that 25 can be factored more. So the same thing goes for polynomials. So we always want to check to see if we can factor any of our factors more. So going back to the problem we just did, the easiest way to tell that you're done factoring is that what we call linear factors, which are degree 1 polynomials, so no exponent on the variable. If you've taken the GCF out, so if there's no GCF, all linear factors are prime. So once you get down to the point where you have a polynomial and inside the parentheses and there's no exponent on the variable, that one can't be factored anymore. Theoretically, the other one could be, but in this case it can't because that's also a linear factor. So if it's not a linear factor, then we try to factor using our strategy again, and either it works or it doesn't work, but if it's not linear, we have to at least try. So now that we have our full strategy, we're just going to do a bunch of examples. This is one of those things where it looks like there's a bunch of different types of problems, but you kind of find that you do the same thing over and over and over again. They just look a little different. So let's do a higher order polynomial. Let's factor 18 x to the 6th minus 57 x to the 3rd plus 30. Okay, what do you guys want to do first? Sorry? Yes, GCF. And thank goodness it has one because 18 times 30 is a really big number. So, but all three of these coefficients are divisible by 3, so I can factor a 3 out. So we have 3 times 6x to the 6th minus 19, just kidding, x to the 3rd plus 10. And at this point, remember I told you guys when you put that 0 in, when you have two terms, that the way you figure out what your variable factor is that the exponent should be half the exponent in the first term. So that's a way that you can check if this factors as well. If you have a trinomial and you've taken the GCF out, if the exponent on the middle term is not half the exponent on the first term, then you have no hope. It's not going to factor. So if you're factoring a trinomial, once you've taken the GCF out, the exponent in the middle term has to be half the exponent in the first term, or else it won't factor. And the reason is that, like, if you had like x to the 4th plus 2 and x squared plus like 5, and you multiplied those, well, you could get your x to the 6th as your first term, right? But if those two are different, then you end up with 4 terms, and none of them are like terms. And so there's no way to combine that into a 3-term polynomial, which means if we have a 3-term polynomial, it must have come from having like terms in the middle. So that means that this has to be x to the 3rd, and this has to be x to the 3rd. So those can be like terms, and we can combine them. So it has to be somewhat symmetric. Those numbers had nothing to do with the problem we're doing. I just made them up. Okay, so now we're going to do the AC method. And when you have higher order polynomials, the AC method works exactly the same way, because the AC method really just deals with the coefficients, right? So it just deals with the numbers. So what's going on with the variables kind of comes out with the wash. So we have AC equals 60 and B equals negative 19. What are my signs going to be? Are two of the same sign or opposite signs? Two of the same, because multiplying opposite signs would give me a negative. So now that we know that they're the same, are they both positive or both negative? They're both negative because they add to a negative. So we have two negatives. And if you find yourself choosing wrong, one thing you can do is once you make that choice, you can be like negative times negative equals positive. Negative plus negative equals negative. And then you're like, oh yeah, my product is positive and my sum is negative. So you've just checked that your signs actually work for the numbers that you have. So we have 160, 230, 320, 415, 512, 6, 10, 7, 8, 9. Yep, that's it. Make everybody negative. And -4 and -15 work. So we have 3. Remember that 3, our GCF is just hanging on for the ride. And we'll rewrite 6x to the 6th. And then when we rewrite that middle term as 2 terms, remember those 2 terms have to add to -19x to the 3rd. So they're both going to have a variable factor of x to the 3rd so that they're like terms and they add to a term with a variable factor of x to the 3rd. So you just want to make sure when you split up that middle term that you keep that same variable factor, like whatever's already there. So we have -4x to the 3rd minus 15x to the 3rd plus 10. And now we can factor by grouping, so we will factor out, what is that, like a 2x to the 3rd, 3x minus 2, and then a -5, and we have 3x minus 2. Another place where you can check that you have chosen your numbers correctly is that if you, at this point, if you don't have common binomial factors, then your numbers, the 2 numbers you chose, aren't correct. So if you find 2 numbers that multiply to give you your AC and add to give you your B, you will always get common binomial factors here. So we got our 3x minus 2 and 3x minus 2. If you don't get that, then you didn't choose the 2 numbers correctly. So we have 3 times 3. Oh, this is a 3. X to the 3rd minus 2 times 2x to the 3rd minus 5. That is a lot of 2's and a lot of 3's. So then the last thing we're going to do is check to see if we can factor any further. So we would start with, and you can do this over on the side, so starting with 3x to the 3rd minus 2. It has 2 terms, so I'm going to put a middle term in. So we have 3x to the 3rd, and then plus 0. But then to figure out what the variable factor of that term is, I need half of the exponent in the first term, right? And since this is a polynomial, we can't have decimal or fractional exponents, which means I'm done. Like, it just can't be factored because I can't put a 1.5 here. And the same would go for the other one because it also has x to the 3rd as the first term. And so that polynomial is fully factored now. Let's do this one last one because it looks a little bit different. Let's factor 4 times x minus 2 to the 4th minus x minus 2 to the 5th. How many terms does that polynomial have?
2.
Very good. So it has 2 because we're looking for addition and subtraction outside the parentheses to separate our terms, right? So the only addition or subtraction outside the parentheses is that minus sign right after that exponent of 4. And so that means this is one term and this is our second term. Do those 2 terms have any common factors? X minus 2. And in fact, they have more than one factor of x minus 2 in common, right? So that first one has 4 factors of x minus 2 and the second has 5. So I can really factor out x minus 2 to the 4th. So that's my GCF. And then when I take x minus 2 to the 4th out of that first term, what am I left with? 4, yeah, just a factor of 4, right? And if you're ever unsure about the answer to that question, you can literally like take it out. Like just like erase that x minus 2 to the 4th and be like, oh yeah, there's a 4 left. So we have a 4. And then between my 2 terms, I have subtraction. And then if I take a factor of x minus 2 to the 4th out of that second term, what am I left with? Yeah, we're left with a single factor of x minus 2. It needs to be in parentheses because we're subtracting that whole thing. Right? So I put parentheses around the inner x minus 2 because I want to distribute my negative. But then these are the parentheses around my leftovers, so to speak. So within a factor itself, you can simplify. You can like distribute that negative and combine like terms because the only thing happening inside that factor is addition or subtraction. So we can condense that as much as we want. So we have x minus 2 to the 4th. And then 4 minus x plus 2. So x minus 2 to the 4th and negative x plus 6. And then we're done. We could, if we really wanted to, we could factor a negative 1 out of that second factor. The only reason I'm not doing that is because so that process of factoring out a negative 1 so I have a positive first term is something I do when I'm going to factor because all the tools we have for factoring work out nicer when we have a positive first term. When I look at what I have so far, I see that I have linear factors, right? There's no exponents on my variables, so I know I'm not going to be able to factor anymore. So whether or not that first term is positive doesn't really matter because I'm not taking it any further. If that had been like negative x squared plus 9, then maybe I could factor it more, so I'd pull out the negative 1. So like I said before, a lot of these look different, but if you follow that strategy that we wrote down, just kind of step by step and just take it really systematically, you'll find that you just do the same thing. The process is the same, even when they look different. All the questions that I ask you guys when we do these together, you want to ask yourself in your head, like, what should the signs be before you start? You know, because it's easy to just jump right in and start writing stuff, but then we find ourselves with some funny signs. Okay, I have